Welcome to this tutorial where we will dive deep into creating a decentralized autonomous organization, commonly known as a DAO. DAOs are an innovative concept in the blockchain space, allowing communities to operate without centralized control. By the end of this video, you'll have a solid understanding of how to set up your own DAO using Ethereum smart contracts. Before we get started, let's go over what a DAO actually is. A DAO is an organization represented by rules and coded as a computer program that is transparent, controlled by organization members, and not influenced by a central government. It's typically hosted on a blockchain like Ethereum. To create a DAO, you usually need a few components. First, you need a smart contract to govern the organization. Next, you need to define the governance structure. This includes how decisions are made and how voting works. Lastly, you'll often need a cryptocurrency to facilitate transactions and incentivize behavior. Now, let's set up our development environment. For this tutorial, we will use Node.js, Truffle, and Ganache. If you haven't already installed these tools, here are the commands for installation. After installing, let's create a new directory for our DAO project. We will call it MyDAO. Here, we've initialized a new Truffle project. You should see a structure with directories like contracts, migrations, and test. The contracts folder is where we'll write our smart contracts. Now let's create a new smart contract for our DAO. In the contracts folder, create a new file named mydao.sol. We will be using Solidity, the programming language for Ethereum smart contracts. Let's start by writing a basic structure for our DAO. We will define the contract, its owner, and some basic functionality. Now, we've defined an owner for our DAO, which is the address that deploys the contract. Next, we need to add functionality for voting. In the code above, we define a structure called proposal to encapsulate the details of a proposal, including its description and the number of votes it has received. We also declare a mapping to keep track of all proposals and a count of proposals created. Next, we will allow members to vote on a proposal. Here's how you can add a function to handle voting. In the vote function, we ensure that an address cannot vote twice on the same proposal and check if the proposal ID is valid. When a vote is cast, we update the vote count for the respective proposal. Now, let's add a mechanism to conclude voting and determine the winning proposal. Here's the function for that. This function loops through all proposals, checks their vote counts, and returns the proposal with the most votes. You might want to implement additional checks such as ensuring voting is ended before calling this function. But this gives you the basic structure. Now that we have our smart contract structured, let's compile it using Truffle. In the terminal within your MyDAO directory, run the following command. If everything is set up correctly, you should see messages indicating that the contract was successfully compiled. Next, we need to deploy this contract locally using Ganache, which simulates a blockchain environment. Let's initiate Ganache. You can do this by running the command below, which will give you a local blockchain to work with. Now, let's create a migration script to handle the deployment of our smart contract. In the migrations directory, create a new file called to_deploy_mydao.js. This script imports our DAO contract and tells Truffle to deploy it. Now we'll run the migration to deploy our contract to the local blockchain. After running the command, you should see output in the terminal that indicates our contract has been deployed. Make a note of the contract address as you'll need it to interact with the contract later. Next, we need a way to interact with our DAO from a front-end application or directly from the script using Truffle console. First, let's open the Truffle console by executing the command below. Once you are in the Truffle console, let's get the instance of our deployed contract. Now that we have the instance, we can create a proposal. Let's do that with the following command. When this executes successfully, it means we've created a proposal. You can verify it by retrieving the proposal using its ID. Now let's simulate voting for the created proposal. We will cast a vote with the following command. Once you've voted, let's retrieve the proposal again to see the updated vote count. Finally, let's conclude the voting process and get the winning proposal. We will call the conclude voting function. And there you have it. You successfully created, voted on, and concluded a proposal in a DAO. Remember that DAOs can have more complex governance structures, such as different voting weights, quorum requirements, and even integration with off-chain signatures. As you continue to explore DAOs, consider scalability and gas costs as you develop. DAOs are becoming increasingly important in the crypto ecosystem, allowing for decentralized funding, governance, and collaboration. Thank you for following along this tutorial on how to create a DAO from scratch. If you found this video helpful, please give it a thumbs up and be sure to subscribe for more programming tutorials. Let us know in the comments what projects you plan to work on with DAOs.